So welcome to this video. We'll begin over the Cambridge International A-Level Maths November 2020 Pure 1 Variant Free paper. Let's go. So first question, we just need to express this quadratic equation in x plus a squared plus b, where a and b are constants. So fairly simple, we just need to complete the square. So what I'll do for this one is if we complete the square, we will get x plus 3 squared. And then we would have to minus a 9 out of that. And then we still have the plus 5. Therefore, this would just equal x plus 3 squared minus 4. And that's that question done. And for the second question, okay, it says that the curve of equation y equals x squared is transformed to the curve of equation y is equal to x squared plus 6x plus 5. Describe fully the transformation involved. Well, from the previous question, okay, we know that x squared plus 6x plus 5 is the same as x plus 3 squared minus 4. So what we can do is we can just compare that with x squared, okay? Because if I just move this over here, so let's just move this over here, right? If we just compare this with x squared, okay, what is the transformation happening here? Well, it's actually fairly simple to know what's happening, okay? Let's think about the x coordinate first. Well, we have the x plus 3. So what does that mean? That means that we have shifted to the left. Okay, we're shifted to the left by 3 units. And with that minus 4, that just means that we've shifted down. Okay, we've shifted down by 4 units. Okay, so that's all that we've done. And I guess the best way you could say this is what you can say what I've said. An easier way would just say that it's a translation. Okay, it's translation of, and then what we can do is we can write minus 3 minus 4. So this translation, that says the same thing. It just says that we've moved 3 units to the left and we've moved 4 units down, okay? So for question 2, we need to integrate between the limit of infinity and 1 of f of x, where f of x is 2 over x plus 2 squared, when x is greater than minus 2. So I'm going to rewrite the f of x first. So I'll rewrite it as a 2 and then an x plus 2 to the minus 2. And now if we integrate this, okay, so we have infinity here, we have 1 here, of if we integrate x plus 2 and then the minus 2, what would that be, okay? So again, we just need to plus 1 to the power and then divide by our new power. So that would be a 2, we'd still have that, and then we'd have an x plus 2 to the minus 1, and then that would be, everything would be divided by minus 1. So we'd be left with a minus 2 x plus 2 to the minus 1, which then is a minus 2 over an x plus 2. So now let's put our limits in now. So with the limit of infinity, okay, then let's just think of it this way. Let's think of it as a limit as x, okay, tends to infinity, okay, of the minus 2 x squared, x plus 2, okay? So that is, if I put this in brackets, that's the limit of infinity. And then with the 1, if we put that in, we would get a minus 2 over 1 plus 2, which that would be a positive 2 over 3. So now all we need to do is figure out what is the limit as x tends to infinity. So as you can see, if we look at the limit of as x tends to infinity, right, it's just going to get smaller and smaller and smaller, right? Because think about it. If, let's say, x was 1, then we get minus 2 over 3, okay? Then if x is 2, we would get minus 2 over 4, okay? And then as we keep going, let's say x was like 10, we get minus 1 over 6. And if x was 100, we'd get an even smaller number, right? Because the bigger the denominator, the smaller the value is going to be. So therefore, as x is going to infinity, it's the value is just going to tend towards 0, okay? Therefore, it would just be 0 plus 2 over 3. Therefore, answer is just simply going to be a 2 over 3. For part B, we're told that the equation of the curve is such that dy over dx is equal to f of x. It is given that the point -1 lies on the curve. Find the equation of the curve. So if dy over dx is equal to f of x, that means that dy over dx is equal to a 2 times x plus 2 to the power of -2, okay? So therefore, what we need to do is we need to integrate this, okay? And then we have our plus c, we can put in our values. Now, due to the previous question, we actually know what this is, because in our previous question, we had to integrate f of x. So now that dy over dx is equal to f of x, well, we know that if we were to integrate this, okay, that would just be y is equal to a -2 over x plus 2. And then don't forget our plus c now, because before we had limits, now we don't have limits, so we now have our constant plus c. And we're told that we have -1, they are points on this curve, so therefore we just put those points in. So it's -1 is equal to a -2 over a -1 plus a 2, which is a 1, plus a c. Therefore, we get a -1 is equal to a -2 plus c. Therefore, c is equal to 1. And therefore, if we write the full equation now, that'll just be y is equal to a -2 over x plus 2 plus 1. So for question 3, we need to solve the equation 3 tan squared theta plus 1 is equal to 2 over tan squared theta when theta is between 0 and 180. So what I'm going to do first is I'm going to multiply everything by tan squared theta first. So if I do that, I get a 3 tan to the 4 theta plus a tan squared theta, and that is equal to a 2, okay? And then I'm going to get 2 to the side, so we get a 3 tan to the 4 theta plus a tan squared theta minus 2 is equal to 0. And now we have pretty much an equation here now in terms of tan theta. So what I'm going to do now is I'm going to let y equal a tan squared theta. So if I do that, well, now we would get a 3y squared plus y minus 2 is equal to 0. And now we have a quadratic equation. Now, if you were to put this into your calculator, you would get y as 2 over 3 and y as a -1, okay? So, therefore, now let's put back in our tan theta or tan squared theta. Could we say that y is equal to tan squared theta? That this must mean now that tan squared theta is equal to 2 over 3, and also tan squared theta is equal to a -1. Now, if we start with the tan squared theta is equal to -1, well, that is impossible, right? Because you can't square a negative. Therefore, we can just disregard this here. So now we're just left with tan squared theta is equal to 2 over 3, which means that tan, oh, let me change my thickness, which means that tan theta is equal to the square plus or minus the square root of 2 over 3. So now we can now draw a cast diagram. If I draw my cast diagram here, okay. Now with our cast diagram, this would be all stations towards Croydon. So with my cast diagram now, as you can see, our tan theta will have a positive and will have a negative values, which means that we're going to be in every single quadrant, okay? So if you work out tan theta, if you work to the inverse tan of the square root of 2 over 3, you will get to one decimal place 39.2. But that 39.2, because we're going to get a positive and a negative, we are going to be in every single quadrant, okay? So we're going to write 39.2 in all of our quadrants here, like this. And then in the question, they tell us that theta is between 0 and 180. So therefore, we just need to choose the values between 0 and 180. In our case, that will be 39.2 is one of them. The other one would just be in that sign quadrant, which would be a 180 minus the 39.2, and then that would be 140.8. Okay, so we've worked out our 2 points. It would be so my pen's acting up. It would be a 39.2 degrees and a 140.8 degrees. So question 4, okay, we have this curve as equation 3x squared minus 4x plus 4, and with the straight line that has equation y equals mx plus m minus 1, where m is a constant, and we find a set of values of m for which the curve and the line have two distinct points of intersection, okay? So pretty much it's a discriminant question, and effectively we need to work out this b squared minus 4ac, and when that is greater than 0, because that's when it'll have two distinct points of intersection. So if the curve and the straight line intersect, that must mean they must be equal to each other at some point. Okay, so if I do that, we get a 3 squared minus a 4x plus 4, and that must equal the mx plus m minus 1. And then we're going to bring everything to the same side. So if we bring everything to the left side, that would be a 3x squared, okay, minus a 4x minus an mx, and then we would have a, bring that minus 1, so we get a plus 5 minus an m, and that is equal to 0. So now I'm going to just rewrite this a bit differently, and rewrite this as a 3x squared, say the same. Now I'm going to take out the factor of x, so we'd get a, as a plus, we would get a minus 4 minus m x, okay? And then for this, I'm also going to write this in brackets, the 5 minus m. So now we can clearly see that this is a quadratic equation, okay? We will clearly have our a, b, and c values. Okay, this will be our a value, all of this will be our b value, and then all of this would be our c value there. So therefore, let's write that here where we know that a is equal to 3. Okay, we have b equal to minus 4 minus m, and we have c, and that's equal to a 5 minus an m. Then if we do b squared minus 4ac, and we make this greater than 0, then what would that be? Okay, so that would be a minus 4 minus m squared minus a 4 times a 3, so that's a minus 12 times a 5 minus m, and this will have to be greater than 0. So what do we get this here? So we get a positive 16, we get a 4m plus a 4m, so an 8m, then a minus m times a minus m, so that's a positive m squared. Then we get a 12 times 5, so minus 60, and then a positive 12m, and that must be greater than 0. So if I rewrite this, we would have an m squared here, plus a 20m, and then we would have a minus a 44, and this must be greater than 0. So now we need two numbers which multiply to make minus 44 and sum to make a 20. So that would be a positive 22 and a minus 2. So therefore, m plus 22, m minus 2. Okay, this would have to be greater than 0. Therefore, if I just put the values here, we get m is equal to minus 22, and we get m is equal to 2. And if I just draw a little graph here just to show the quadratic, what this would look like, then with this graph here, okay, so we know that it's going to be a positive, it's going to be the U shape. It'll be just something like this, for example, where this is a minus 22, and this point here would be a 2. We want it when it's greater than 0, so we want it's going to be all these points. That's when it's above the x-axis, okay? So therefore, looking at that, we now know what our inequalities will be. So we know that for this to have two distinct points of equation, m would need to be either less than minus 22, or m would need to be greater than 2. So question 5, okay, we've got this expansion a plus bx to the power of 7, where a and b are non-zero constants. The coefficient of x, x squared, x to the 4 are the first, second, and third terms, respectively, of a geometric progression. And we need to find the value of a over b. So, therefore, all we need to do first is let's find what the coefficients of x, x squared, and x to the 4 is. So we have a plus bx to the power of 7, okay? So to find those coefficients, well, we know that if we have 7, choose 1. Okay, that'll be a to the power of 6 times by b to the x, okay? So that, oh wait, no, not b to the power of x, my bad, just b to the x, okay? So that's the x1, now that's the x1. We would also get, if we want x squared, okay, that'll be 7, choose 2, okay, and that would be a to the 5, and that would be a b squared x squared, so that'll be our x squared. And then for x to the 4, that would be a 7, choose 4, times by a to the 3, and then b to the 4x to the 4, okay? So now let's work out these values. So if we work out these values, then what do you get? Well, you get a. So 7 to 7, that's just a 7, a to the 6, bx, okay? And then for the next one, okay, what do we get? Well, 7 choose 2, okay, that is 21. So that'll be a 21 a to the 5 b squared x squared, okay? And for 7 choose 4, that's a 35. So 35 a to the 3 b to the 4 x to the 4. And we know that the coefficients, they form a geometric progression, okay? They're the first, second, and third terms. So look at the coefficients now of these. That must mean that it would be a 7 a to the 6 b, and then 21 a to the 5 b squared, and then a 35 a to the 3 b to the 4, okay? These would be the first, second, and third terms. And if this is a geometric progression, then we know that they all must be times by the same value, so times by r to get to the next term. So now we've worked out that, well, now we can form an expression for r, going to have simultaneous equations, and we can work out a over b. So if we do that here, well, if we know 7a to the 6b times r gives us 21a to the 5b2, then effectively we know that r is equal to a 21 a to the 5b squared, and that is over a 7a to the 6b, okay? And we can simplify this down, okay? Because you can see 21 and 7, okay, so that will become a 3 here. All of this can go, and we're just left with a 1 here, and then this will get cancelled out with this. So what are we left with? Well, we are just left with simply a 3 b over a, okay? So 3b over a. So we know that r is equal to 3b over a. Now we're going to do the same thing with this one here, okay? So we know that 21a to the 5b squared times r is equal to the 35a 3b to the 4. We're going to do the same thing there. So therefore, for this one here, we would get a r is equal to a 35 a to the 3b to the 4, and that is over a 21 a to the 5b squared. And again, let's just simplify this down a bit. So both these go into 7, okay? So this would be a 5, this would be a 3. All of this goes, left with a 2 here, and all of this goes, and we're left with a 2 here. So therefore, this one, it would equal a 5 b squared, okay? And that will be divided by a 3a squared, okay? So we've got r is equal to 5b squared over 3a squared. And then we know that our r's must be equal to each other because they're the same value. Therefore, we know that a 3b over a is equal to a 5b squared over a 3a squared. And now we want to try and get this into some form of a over b, okay? So if we just cross multiply, so if we cross multiply, what do we get? Well, we get a 9 a squared b, okay, if we cross multiply, and that is equal to a 5ab squared. And now let's start to cancel out what we can cancel out, okay? And now let's actually bring that 5ab squared to the other side, okay? So let's do that. So if we do that, we are left with a 9a squared b minus a 5ab squared, and that's equal to 0. If we factorize now, that would be an ab, okay, ab, and then we would be left with a 9a minus a 5b, and that's equal to 0. And as you can see, either a times b has to be 0, or 9a minus 5b has to be 0, okay? So in this case, we know that we has to be the 9a minus 5b, because both a and b are non-zero constants. Therefore, 9a minus 5b would have to be equal to 0. Therefore, 9a is equal to a 5b. As you can see, we can now rewrite this for a over b now. We just bring the b to the side, bring the 9 to the side, and therefore a over b is simply equal to a 5 over 9. So this question, okay, we have f of x equal to 2x over 3x minus 1. We need to find an expression for f to the minus 1x, so just find the inverse of x. So to do this one, that'll just be, I'm going to make x equal to 2y over a 3y minus 1, and then want to rearrange, make y the subject of the formula, and that should give me my inverse. So if we do that, that would be a 3xy, okay? And that would be a minus an x is equal to a 2y. And now let's bring all my y's on the same side. So we get a 3xy minus 2y is equal to an x. If we take out a factor of y now, we get a y is equal to a 3x minus 2 is equal to x. Therefore, we have that y is equal to an x over a 3x to the minus 2. Okay, for part B, we need to show that 2 over 3 plus 2 over 3 times 3x minus 1 can be expressed as 2x over 3x minus 1. So effectively, we just need to, I guess, just work out that fraction, okay? So to do that, well, with the 2 over 3, what we can do is if we times that by a 3x minus 1, we would get a 2, and that would be a 3x minus 1, okay? And that would be over a 3 times a 3x minus 1, and that would be plus the 2 over a 3x minus 1. Then if we join that all together now, we would get, well, let's expand the brackets on the numerator. So we get a 2 times 3x, that's a 6x. Then we get a minus 2. Then we get a plus 2. And that will be all over the 3x minus 1. And therefore, the 2's are cancelled out, so we're left with a 6x over a 3x minus 1. And then, as you can see, this can cancel out. So we're simply just left with a 2x over a 3x minus 1. And for part C, okay, we need to find the range of f, okay? So the range of f. So if we go back over here, the range of f. So the domain is when x is greater than a third. And if we think about this, well, what else do we know? Well, we know that 2x over 3x minus 1 can be written as this over here, 2 over 3 plus the 2 over 3x minus 1, where x is greater than a third. So think about it. The key is a domain here. X is greater than a third. So when x is greater than a third, what actually happens to this value? Well, it's just going to be a positive value, okay? It's never going to be a negative. It'll always just be a positive value, okay? And as a result, because this bit here will always be like a positive value, okay? Then what do we know about all of this? Well, what do we know? Well, we know that it'll always be like 2 over 3 plus some value, okay? It will always be that. It will always be 2 over 3 plus some value. And as a result, because it will always be 2 over 3 plus some value, therefore the range would just be 2 over 3, because it will always be 2 over 3 plus some positive value, okay? That positive value can get very small towards 0, but it can also be very big as well. So it'll just be 2 over 3, okay? So therefore, it will just be f of x is 2 over 3. For this question, we have the first and second terms of an arithmetic progression are 1 over cos squared theta and minus tan squared theta over cos squared theta, respectively, where theta is between 0 and pi over 2. Show that the common difference is minus 1 over cos to the 4 theta. Okay, so we know the first two terms, so we know that it's going to be a 1 over a cos squared theta, and then we'll have a minus tan squared theta over a cos squared theta, and we know that it's an arithmetic progression, so there's going to be a common difference, so we're going to plus d, and that gives us that. So effectively, it's 1 over a cos squared theta plus d is equal to a minus tan squared theta over a cos squared theta, which therefore means that d is equal to a minus tan squared theta over cos squared theta, and that's minus a 1 over a cos squared theta. Now we can put this all over one single fraction, okay, because they both have the denominator of cos squared theta. Therefore, we get a d is equal to a minus tan squared theta minus 1, and that's all over a cos squared theta. And now there's just one thing to know. I believe this is in the formula book as well, but one of the trig identities we know is that we know that a 1 plus a tan squared theta is equal to a sec squared theta. In our question, we have minus tan squared theta minus 1. So therefore, if we just minus 1 to everything, that will give us and if I rewrite this as a minus tan squared theta minus 1, that would equal a minus sec squared theta, okay? So know that a minus tan squared theta minus 1 is equal to a sec squared theta. Therefore, for our question, we have that d is equal to a minus sec squared theta over a cos squared theta, okay? And now at this stage, well, what is sec squared theta? Well, we know that sec squared theta, that's the same as 1 over a cos squared theta. So therefore, in our question, that's the same as saying a minus 1 over a cos squared theta, and that will be divided by a cos squared theta, which is the same as timesing by a 1 over a cos squared theta. Therefore, working this out gives us our d, and our d would be a minus 1 over a cos to the 4 theta. Okay, and now for this question, we need to find the 13th term when theta is pi over 6. So to work out this, when we have an arithmetic progression like this, well, to work out a term, it would be an is equal to a1 plus n minus 1 times d, okay? In our case, we'll look at the 13th terms. That will be a13 is equal to a1 plus 13 minus 1, so that would be a 12d, okay? So a1 plus 12d, let me just rewrite that plus a bit better. And now, well, how can we work out our a1 value? Well, in the previous question, we know that 1 over cos squared, that's the first term. So we can work out a1. So a1 is just 1 over a cos squared theta. So that is a 1 over a cos squared and then pi over 6, okay? And then if you work that out, you would get a 4 over 3. You get a 4 over 3. So we know a1 is 4 over 3. And we look at our d value. Well, we know d from the previous question. We know that our d is a minus 1 over a cos to the 4 theta. So therefore, that's a minus 1 over cos to the 4, and then we still the pi over 6. And if you work that out as well in your calculator, you get a minus 16 over 9. Okay, so we worked out a1 and our d value. Therefore, a to the 13, we now know is just going to be a1, which is a 4 over 3, plus a 12 times d, which is in our case a minus 16 over 9. If you put that all into a calculator, you would get the grand total of a minus 20, okay? So we know that the 13th term is a minus 20. Okay, for this question, we need to work out dy over dx and d squared y over dx squared. So for y, I'm just going to rewrite this as a 2x plus 1, and then that will be a plus a 2x plus 1 to the minus 1, okay? And now let's work this out, okay? So dy over dx, well, that would just simply be a 2, and then the 1 would cancel it out. Then 4 we get a 2 times a minus 1, okay? So that would be a minus 2, and then in brackets we still have the 2x plus 1, and that will be to the minus 2. So that's dy over dx, okay? And then for the second bit, well, we just need to differentiate again. So d squared y over dx squared. Well, therefore the 2 would cancel out, and we would get a minus 2 times a minus 2. Then don't forget that we another times a 2, because the 2 will come out of the bracket. So it's a minus 2 times a minus 2 times a 2. So that would be a positive 8. And then in brackets, we get the 2x plus 1. And then now that would be to the minus 3. Now for part B, we need to find the coordinates of the stationary point and determine the nature of the stationary point. So when they say determine the nature, what they mean is pretty much we want to figure out, is this going to be a minimum point or like a maximum point, right? Like is the stationary point a minimum or a maximum? And to do that, we actually will need the d squared y over dx squared. But enough of that, let's just work out dy over dx equal to 0. Let's work out our stationary point first, and then we can worry about the nature later. So what do we know? Well, we know that, as just said, that dy over dx, okay, we know that that is equal to 0. That will give us our stationary point. So in our case, what would that be? Well, in our case, we know that dy over dx, okay, that is equal to a 2 minus a 2, and then that's not that, that's a 2x plus 1, okay, and that is to the minus 2, okay? And we know that that would have to equal 0. So if I do that here, we get a 2 minus, I'll just rewrite this differently now. I'll rewrite it as a minus 2 over a 2x plus 1 squared, and that has to equal a 0. Make that 2. My pen is just a new pencil tip, I believe. Like this, okay? And now let's work this out. So if I work this out, then we would actually end up with a 2 is equal to a 2 over a 2x plus 1 squared. Therefore, a 2x plus 1 squared has to equal a 1. And now we would square root. So we get a 2x plus 1 is equal to plus or minus 1, okay? And therefore, we would get a... Let's consider when it's positive first. So actually, let me different pen. So therefore, it would be a 2x plus 1 is equal to 1. Therefore, we know that 2x would be 0. So then x would be 0. So that's one of the conditions. And the other one, if it's minus 1, okay, so we get a 2x plus 1 is equal to a minus 1. Then we get a 2x is equal to a minus 2. Therefore, we get x is equal to a minus 1. Okay, so we have both these two conditions here. However, in the question, okay, go back to this question here. We actually have a domain. We have a domain that x has to be greater than minus a half. So because x has to be greater than minus a half, we can actually just disregard this one here, because this is minus 1 that is not greater than minus a half. So therefore, we only would consider this value here when x is greater than 0. So that for this one, x is 0, okay? And then to work out that point, okay, well, in our original question, we had y is equal to 2x plus 1 over 2x. So in that case, in that question, it would be y, different color. Let me just rewrite y. So we have y. So y, it was y is equal to 2x plus 1 plus, let's write this, 1 over a 2x plus 1. So now if we work out what y value is, well, y would equal 2 times 0 is 0. So we're left with a 1 plus another 1, therefore 2. Therefore, we know the coordinates is going to be a 0, 2, okay? So we know the coordinates is a 0, 2. So now we need to determine the nature of this stationary point. So how do we determine the nature of this stationary point? Well, there is something we need to consider. That if what they're asking you to do is they want you to figure out, is this stationary point a maximum or a minimum point? So to work that out, well, if d squared y over dx squared, okay, if this is less than 0 at that stationary point, then it would be considered a maximum, okay? And if d squared y over dx squared is greater than 0 at that stationary point, then it would be considered a minimum, okay? So all we need to do is, what is our d squared y over dx squared? Well, we know from the previous question, okay, that is 8, and that's a 2x plus 1 to the minus 3. Now, let me rewrite this actually as an 8 over a 2x plus 1 to the 3, okay? And what we're saying is if we put in our stationary point, in this case it was 0, right? The x value of our stationary point was 0. If we put that in, if that value is greater than 0, it's going to be a minimum. If it's less than 0, it's going to be a maximum. So we put in our value. Well, our value was just 0. So therefore it would be equal to an 8 over a 2 times 0 plus 1 cubed, which is just a 1. So that would just be 8, okay? So therefore, because we have 8, that means that d squared y over dx squared is actually going to be greater than 0. Therefore, we can say that the nature of the stationary point is a minimum, okay? Okay, question 9. Okay, we have this diagram here. We have arc AB, it's part of the circle with center O, radius 8. We have arc BC, it's part of the circle with center A and radius 12. And we have AOC is a straight line, and we need to find angle BAO in radians. So we need to find BAO, so it's this angle here. We need to find this angle here. So how can we do that? Well, we actually know all of the sides, okay? We know this side is 8, we know this side is 8, and we know this side is 12. So actually, we can just use the cosine rule, okay? So if I just draw here, so let's say it won't be too accurate, but let's say it's something like this, okay? Then we know that this side is 8, this side is 8, this side is 12, okay? And all we want is we just want this angle right here, okay? Because this is angle BAO. So therefore, we can use cosine rule for that. If I just label all of this, let's label this A, let's say this is B, for example, and this is C, then we can use cosine rule. So what is cosine rule? Well, cosine rule states that, actually, let me also label this. This is like capital A, and then this is a capital B, and this is a C. Cosine rule states that it'll be cosine A, and that is equal to a B squared plus C squared minus A squared, and that is not all of it. This bit is over a 2 BC. Okay, so therefore we can now work that out, because in our case we'll have a cosine of x, okay, and that is equal to a 12 squared plus 8 squared minus 8 squared, and that is over a 2 times 12 times 8. So we get a cos x is equal to a, we're actually lucky here, because the 8 squared to cancel out, so we're just left with a 12 squared, which is 144 over 2 times 12, 24 times 8, 192, okay, 192. And then that actually simplifies down to 3 over 4, so cos x is equal to 3 over 4. You can put that into your calculator. Remember that we want it in radians as well. The question does say work out in radians. Just be careful. Make sure you do it in radians, not degrees. So if we do the inverse of cos of 3 over 4, okay, make sure you're in radians. You will get x is equal to 3 significant figures, 0.723 radians, okay? So that would be that question. And for part B now, we need to work out the area of the shaded region. Okay, so we'll go back to this diagram. I'll probably just do it here. So if we look at the area of that shaded region, well, if we look at the shaded region, okay, what can we work out? Well, we actually can work out the area of this arc here, okay? We can work out the area of this arc, and we can work out the area of this triangle here, and then we can just do the area of the arc, subtract the area of the triangle, and we can get the area of the shaded region. So let's work out the area of the arc first, okay? So we'll do up here. We know the area of arc, so we know the area of the arc BC, okay? So area of arc BC, that's just going to be a half r squared theta. So that'll be a half times, what is the radius in this case? Well, of BC, the radius is 12, okay? So it'll be times by 12 squared. And the theta, well, that would just be what we worked out in the previous question. That would be actually angle BAO. So that would be the 0.723. And if you work that in your calculators, okay, remember to try and be as accurate as you can with these questions. That will give us two free segment figures, just 52, okay? We get 52.0. So let's say it's just 52. So now it works out the area of the arc, and let me just write a different color so we can see it differently. So now the area of the arc is 52. Well, let's look at the area of the triangle, okay? Well, the area of the triangle, so area of triangle ABO. Now the area of the triangle ABO, well, we can use the fact that we can use a half AB sine C to look at the area of that. And we have the included angle because we worked that out in the previous question. So it will just be, remember, if it's this angle here, then it would be the two sides like right next to it, so 12 and 8. So in this case, it would be a half times 12 times 8 times sine again of that 0.723. Okay, I need to get a new pen tip. 723. And if you work that out to one decimal place, you get a 31.7. And therefore, simply just do a 52 minus a 31.7, and you get to three segment figures, you get a 20.3, okay? And for part C now, look at the perimeter of this shaded region. So the perimeter of this shaded region, well, we actually already know two sides of it, okay? We already know that this side is a given to us as 8. We actually know what this side is, because remember that the arc BC, right, has a radius of 12. And because center A, right, center A, any point on the arc would have 12. So if we go here, this must be also equal to 12. Therefore, we know that this is just a 4. So we've got 8 plus 4. Now we need to work out the length now of this arc. And then we can just add up all those points. Look at the length of this arc. Well, we know the equation for a length of an arc, okay? It's just going to be L is equal to R theta. In this case, that'll be L is equal to the radius, which is, again, it's still going to be 12. So 12, and again, times by that theta, 0.723. You work that out to three segment figures, you get 8.67. Therefore, we just need to do 8 plus 4 plus 8.67, okay, because this value here would be 8.67. Just add them all up, and you get 20.67. So three segment figures, 20.7. Question 10 now, we have this curve with this equation here. And we got when k is a positive constant, x is greater than 0. It is given that when x is equal to 1/4, the gradient of the curve is 3. Find the value of k. It's a pretty nice question. We need to differentiate this. Once we differentiate it, then we can plug in our x as 1/4, and then our dy over dx, that would be 3. And then we can use that to work out our k value, okay, where k is a positive constant. So let's just go about differentiating this, okay? So if we differentiate, we get dy over dx, okay? And that would equal so we get a 1/k times a half. So 1/k times a half, that is a 1/2k, okay? X, and then we bring the power down by 1. So we get minus a half. Then for that second value, that would be 1 times a half, so minus a half x to the power of minus 3/2. And then for that last one, well, that's a constant, so it just disappears, okay? So this is what we got for dy over dx. And we know that, as they tell us in the question, when the gradient of the curve is 3, so when dy over dx is equal to 3, okay, x is 1 over 4. So write one more down. So we get 3 is equal to 1 over a 2k, okay? And then that would be times by a 1 over 4 to the power of minus a half minus a 1 over 2 times by 1 over 4 to the minus 3 over 2. Okay, and now we need to work this out. So we get a 3 is equal to a 1 over 2k. So 1 over 4, if we think about that, if we do the negative power first, so that will flip it, it'll be the reciprocal. So that'll be a 4, and then we would just have a 4 to the power of a half, which is a square root of 4. So that would just be a 2, so we're just timesing by 2. And this one here, again, get rid of the negative first, so do the reciprocal. So that's a 4 to the power of 3 over 2. So square root gives us a 2, raised to the power of 3 gives us an 8. So this one would just be an 8, okay? And therefore we have 3 is equal to a 2 over a 2k minus a 4. Okay, and therefore what we can do is that would be a 7 is equal to a 2 over a 2k. Okay, now that's 7. We can actually get rid of a 2 because 2's in both. So that would be a 2 over 2. We can just get rid of them. So we're left with a 1 over k, so 7 over 1 over k. Therefore, k is equal to 1 over 7. Now, this next question, okay, is given that the integral of that equation, okay, equals 13 over 12, the area, effectively. So, or between that point. So, effectively, we need to work out the value of k. So, this one is very, very meaty, okay, indeed, okay. So, integrating this, so it's fairly simple. We just need to integrate it and then equal to 13 over 12, and then put our limits and all that good stuff to work out a value of k. But it is very, very meaty, to say the least. So let's find the value of k. Well, let's integrate this. So if we were to integrate this, okay, well then what do we get? So we would get a x over k, okay, so I'm doing that. So I'm just putting it all together, and that would be raised to the 3 over 2, because we've added 1 now to the power. And that would be divided by 3 over 2. Okay, and then for this one, again, a similar thing. It'll be x to the half divided by a half. And then for this last one, that would just be a 1 over k squared, and we just need to add x, okay? And then all of that would have our limits of k squared and 1 over 4k squared, okay? So therefore, what would that be? Well, we would get if we divide by 3 over 2, same as in timesing by 2 over 3, so we would get a 2x to the 3 over 2, okay, over a 3k. Then this one would be a 1 divided by half. So this one would be a 2x to the 1 over 2. And then again, we'll just be left with that 1 over k squared x, but I'll rewrite it as x over k squared, okay? And now at this stage now, we can start to put in our limits of k squared and 1 over 4 k squared, okay? So if I do that here, therefore, what do we get? Well, we would get a 2k squared, okay? And just that k squared, that's raised to the 3 over 2 over a 3k plus 2k squared, okay? Raised to the 1 over 2. And then we get an x, so k squared over k squared. It's all of this, and that is minus the 2, and then again we now have a 1 over 4 k squared, okay? And it's all of this to the 3 over 2 over a 3k. And then again we have the plus 2x, so 1 over 4k squared, all to the power of a half, and then plus a 1 over 4k squared over k squared, okay? So we have all of this, okay. So now let's simplify it down. So if we start simplifying down, well, the left side would actually be pretty nice. So in this case, what do we get? Well, we'd end up with a 2k squared. Well, if we think about that one here, okay, that would just be the same as a 2k to the power of 3, right? Because if we do 2 times 3 over 2, it gives us a k to the 3. So we get, actually let me just rewrite that. We get a 2 k to the 3 over a 3k. This one would go down to just k, so 2k. This one would go to 1. And on this side, what would we get? Okay, so on this side here, well, let's think about what we get. So we have a 1 over 4k squared to the power of 3 over 2. So in the brackets, we would get a 1 over 8, okay, 1 over 8k cubed, okay? So we get a 1 over 8k cubed, which would be a 2 times 1 over 8k cubed. So that would be a 1 over 4k cubed over a 3k, okay? And then for this one, we would get a 2 times a 1 over 2k. So that'd just be a k. And this one would just be a 1 over 4. So now let's simplify this down a bit. We can get rid of k, so that would be a 2k squared, okay, over a 3 plus a 2k plus 1. This one would be a minus a 1 over 4 divided by a 3. Now, what is a 1 over 4 divided by a 3? Same as saying 1 over 4 times by 1 over 3. So we get a minus 1 over 12k squared plus k. Actually, not plus. Let's get rid of the minus. So it'd be a minus k minus 1 over 4. Okay, so now we've got all of this. Now we're getting somewhere. Now let's simplify this down even more, okay? So another thing to note as well, now that we've simplified down this much, if I just move my equal sign to this side, remember that it equals 13 over 12, okay? So now we've got that all of this now is equal to 13 over 12. Now let's times everything by 12 to get rid of the fraction, okay? It's times everything by 12. If we times everything by 12 now, well, what do we get? Well, we would get an 8k squared, okay, plus a 24k plus a 12 minus a k squared minus a 12k minus a 3 is equal to 13. Okay, we've multiplied everything by 12. Now we can just collect all our like terms and we should have a quadratic equation. So by doing that, we get a 7k squared. We get a plus 12k. Then we would get a 12 minus a 3 is a 9. Bring that minus the 13 over, so 9 minus a 13. So we get a minus 4. And that is equal to 0. So now we've got a 7k squared plus 12k minus 4 is equal to 0. And if you put those values into your calculator, okay, you will get two values. You will get k as equal to 2 over 7, and you get k as equal to minus 2. In the question, they do say in the previous question here, we have that k is a positive constant, okay? K is a positive constant. Therefore, in this question, we can disregard the minus 2 because it's not a positive. Therefore, our answer is simply just 2 over 7. So question 11, we have this circle center C. It has equation x minus 8 squared plus y minus 4 squared is equal to 100. Show that the point T, which is has a coordinates of minus 6, 6, is outside the circle. So for this question here, well, what do we know? Well, if we think of this circle here, let me just draw the circle here quickly. Let me just use this one here. Let's just draw the circle here quickly. And what we're effectively saying is that we know the center of it. Looking at the equation, we can tell what the center of the circle is. Okay, the center is just going to be 8, 4. And we have a radius of 10, okay, because square root of 100 is just 10. So know that the square root is just 10. So what we're saying is that if this point is outside the circle, then it must have a radius of greater than 10. Therefore, it will be outside the circle. So what we can do is we can put in our values to the circle equation. So we have minus 6, so effectively that would be like minus 6 minus 8 squared. Okay, minus 6 minus 8 squared. And then plus a 6 minus 4 squared. And if we work this out, well, we get a minus 14 squared plus a 2 squared, okay? And that is a 196 plus 4, which is a 200. And the square root of 200 is, if we write this in a third form, it will be a 10 root 2. So because 10 root 2 is greater than the radius of 10, well, hence it is outside the circle. You can write something like this, hence outside the circle, and yeah, we're done. So this question, okay, we have two tangents from T to the circle are drawn. Show that the angle between one of the tangents and CT is exactly 45 degrees. So for this one here, I've drawn my circle, and I've drawn, drawn it with the center C as 8, 4, and I've drawn my T with minus 6, 6. Now what they're saying is if we draw a tangent, okay, so if I try and draw a tangent, then if I draw the tangent here, okay, and then we have another tangent, okay, so we're in this direction here. Oh, sorry, if I just see if my pen is able to do the straight line, then, oh, it doesn't want to do it. Okay, that's fine. Let's just do a wiggly line then. Okay, so if I draw something like this, okay, actually that works out perfectly. Then what they're saying is that it has to be the angle between, okay, so it has to be the angle between one of the tangents and CT. That must be exactly 45 degrees. So if we think about it, if I just draw the triangle, so we know that if I draw a straight line like here, right? We know that with that straight line, okay, there is a right angle there. And if I go all the way back, like this, there we go, here and here. Yeah, what we know? Well, we know this here is a right angle, okay? Because the tangent, when it meets the radius like that, it causes a right angle there. And what we're saying is the angle between one of the tangents and CT. So we know that this is CT, okay? And then we know that this is one of the tangents. So we know that we're actually talking about this angle here, okay? We're talking about this angle right here. We need to prove that that angle is 45 degrees, okay? So how can we prove that that is 45 degrees? Well, we actually do know a lot of information, actually. They've given us a lot of information. For example, we know what the radius is, okay? We know that the radius is 10. So because, well, we worked that out. So we know that this has a radius of 10, okay? And we also know what the length of CT is. In the previous question, we worked that out. That was 10 root 2, okay? So if we think about this as like a right angle triangle, let's just do like a basic right angle triangle for now, okay? So I can easily show it. Then effectively, what we've got here is, let's do it the other way, actually. No, let's do the triangle the other way. So if I think about it like this way, okay? The right angle being up there. Therefore, what do we get? Well, if the right angle was here, okay, well, we know that this is the 10, we know this is the 10 root 2, and we know that this is the x value we want to work out. Therefore, we can just use SOHCAHTOA now to work that out. So we have, this would be the hypotenuse, this is the opposite, this is the adjacent. Therefore, it would just be a sine of x, and that is equal to opposite, which is 10 over 10 root 2. And that would be sine x equal to 10's cancel out, so left with 1 over root 2. And through your trigs, you should know that the inverse of sine when it's 1 over root 2 is simply going to be a 45 degrees. Okay, so for part C, we have the two tangents, they touch the circle at A and B. Find the equation of line AB, giving your answer in the form of y equals mx plus c. So as you can see, I've got my 2 points, which it touches here, and I've called this one A, and then it touches here, and this one's B, and there's a straight line going through here, and yeah, we need to work out the equation of the line. So first thing we can work out is actually, let's look at the gradient first. So we know that that line, it must be perpendicular to line CT. So if we look at the gradient of CT first, it'll be just perpendicular to that. So let's work out the gradient of CT. So that way it would be a 6 minus a 4, and that would be over a minus 6 minus an 8. So that would be a 2 over a minus 14. So that would be a minus 1 over 7. So the gradient of CT is that. Therefore, for AB, we know that our gradient is just going to be simply, let's call it N, is going to be 7, okay? So that the gradient of AB is going to be 7. Now we need to work out, well, figure out some points on this line AB. Well, actually, my graph isn't drawn to scale, but actually, this line here, due to the tangents and everything, it's actually the midpoint of CT. I mean, my graph isn't drawn the best, but actually, in this case, where we have tangents like this, it would be the midpoint of CT. Okay, so it's actually just the midpoint. So the midpoint, that would be a point on this line. So all we need to do is work out the midpoint. Okay, look at the midpoint. Fairly easy to work out the midpoint here. You can just do minus 6 plus 8 over 2, and that would give us a 1. That's so we know our x coordinate is 1. And the same for the y coordinates, we could do a 6 plus a 4 over 2, and that would give us a 5. So our y coordinates are 5. So that 1, 5, this is on that line AB. And therefore, we have 2 points. We can use y, take away y1 is equal to m, x, take away x1. We have all our values. We know it'll be y, take away 5 is equal to m is 7. Then x, take away 1. We rearrange this, okay, 7x minus a 7. And we get y is equal to a 7x minus a 2. So just remember that it's not drawn to scale, but this point here, okay, is actually the midpoint of CT. So you can just work that out, and that will give you your xy coordinates, and then you can use the gradient to work out the equation of that straight line. And then the last question here, find the coordinates of A and B. So intersection, so we've worked out, so if I rewrite everything, okay, we know the equation of the circle is x minus 8 squared, okay, plus y minus 4 squared is equal to 100. And we know that the equation of the straight line is y is equal to 7x minus 2. So to find the coordinates, we can just, it's similar equations, we can work out the x coordinates using this. So we can just put the y value into the circle. So that would be an x minus an 8 squared, okay? And that's plus a 7x minus 2 minus 4 squared, and that is equal to 100. So x minus 8 squared is a plus a 7x squared, and that is equal to 100. And now we just need to expand all this out, and we should get a quadratic, and then we can work out x values. So if we expand this out, we get an x squared minus a 16x plus a 64, and that will be plus a 49x squared, okay? Then we would get a minus 84x, okay? Then a plus 36, and that is equal to 100. Now let's collect what like terms. So we get a x squared plus 49x squared is a 50x squared. Minus 16x minus 84x is minus 100x. And then our constants cancel out, so we get a 64 plus a 36. That cancels out with this 100 here. So therefore, that's just a 0 there. So therefore, yeah, we just have a 0. If we factorize this, take a factor of x out. Remember, do not divide by x. Take a factor of x out, because that x value will still be that's still like a solution, right? So always factor out the x. Don't just divide by x and lose a solution. So if we factor out the x, we get x, and then in brackets 50x. Actually, we can take out more than just x. Let's take out the whole of the 50, so 50x, and now we're left with x minus 2, okay, and that is equal to 0. Therefore, we have two solutions. We have either x is 0, or we have that x is equal to 2. And that is it. The question just asks for the x coordinates of A and B, nothing more. Therefore, we've worked out our x coordinates. One of them is A, and the other is B. So one of them is 0, and the other is 2. And that'll be it for this question, this paper. Not a bad one. There are some questions, well, especially on this question 11, you just have to know that that this is the midpoint here. But other than that question, it was a fairly nice paper. Question 10, 11, definitely, I would say, definitely a bit difficult or very meaty questions. A lot you have to do for the marks, but overall, a decent paper. Yeah, I hope you enjoyed this, and next week I'll have the 2021 paper 1 solutions as well. So yeah, I hope you enjoyed this, and I will see you soon.